One, two, I know you know. Two better than you. Are you on call?
Yep,
Where's the road?
it's about to start right now. Hello. How are you doing? Hello, hello.
Hi, how are you?
Good, thank you. Sorry.
No, that's okay. You didn't get hurt in the accident, did you? Oh my God.
One second. I'm just getting your attendance roll. Dean,
Roll here.
I got you. Thank you.
Mhm.
It wasn't too hard. There's not too many people here, unfortunately. All right. So that's that. Okay. So now I guess let's just start. All right. So before we were going over some of this stuff with Z-score, so I guess we still have to finish up um, F4, and then we still have one more to do after that. So the F4 is not going to take us that much longer to complete this. F5, it is possible that we finish all of this today. Well, then the thing is that I'll be there at school, but I won't really have anything else for us to do. So at that point, if you did not attend the class anymore, that would be fine. It's up to you. If somebody does have a question, then you just contact me. I can go over it, whatever you want. But it is possible that we end up finishing all of this today. If we don't, then we'll leave some of it next time. But just please keep that in mind. All right. Does anybody have any question with that? Joining still, so I guess I should wait a second before I start. Let's wait a couple minutes. Can everybody hear me?
Yes, sir.
I hear you.
All right, wait a little, one more minute. Alright. So what I was saying is that we have, F4 to complete still a little bit of this left. And then we have F5 to complete. But it's quite possible that we end up finishing both of these today. And if we do, I don't know. There isn't anything else for me to go over anymore. So because we ended up not really having any of the exams in class and I let you guys do them at home, that we have some extra class time because of that. And I mean, I'll be there definitely next week, but I don't know, I don't really have anything to do. And then we're not scheduled to be there anymore after that anyway because of final exams. So, next week, I guess, more or less, there is no more class. So this is unfortunately going to be our last class, like regular class meeting. So, just keep that in mind. All right. Does anybody have any questions about anything? All right. So we were talking about Z-score before, so let's just remind ourselves what that was a little bit. So Z-score was Z is equal to X minus the mean divided by the standard deviation. And then in this is what we said, like you could think of this as sort of like the value of interest minus the mean value, all divided by the standard deviation. And this was, we said this was a measure of relative position. So it says the lifetimes of brand A's tires are distributed with mean 41,000 miles and standard deviation 4,200 miles, while brand B lasts for only 36,000 miles with standard deviation 2070. Nicole's brand A tires lasted 36,000 miles, while Yvette's brand B buyers tires lasted 34,000. Relatively speaking, within their own brands, which driver got the better wear? In other words, which one sort of drove their car, I guess, a little better? So all right, so we have Nicole and Yvette. So Nicole, we're gonna see how many, oh yeah, and Z-score also we should mention is the number of standard deviations away from the mean. Because we're gonna take the difference between the value and the mean value, and then we're gonna divide that by the number, by the standard deviation. In other words, how many times the standard deviation is gonna fit into that difference. So in the first case, for Nicole, it says brand A. So brand A has mean 41,000. And standard deviation 4,200. And it says hers lasted 36,000 miles. All right, so what is that? That's negative 5,000 over 4,200. So that's 25 over 21. 1.1905. All right, how do I calculate the Z-score for Yvette? What do I write for that one? Somebody help me here, please.
You use her mileage from the brand A tire and whatever mileage she get from her tires.
Well, Yvette didn't do brand A,
Oh,
but she was
and
doing,
B, she did B, my bad, B.
yeah. So then, but you gotta make sure you use the right numbers, otherwise, you know.
Mhm.
So, okay, but what do I write?
You use the brand B tire would last for 36,000 miles, right? And then
No,
brand B, see, you have it right there. Brand B lasts for 36,000 miles.
no, it says Nicole's brand A tire lasts for 36,000 miles and Yvette's brand B tire. Oh, you're saying this one? This is the,
Mhm,
but what
mhm.
is that? What is that saying though? That's
That's how much of mileage you'll get from the tire?
that's true. On average though,
Yeah.
right? Okay, so that's the average. So then that's this thing.
Mm-hmm.
Alright, so then that should be here. That's correct. Alright, then what? She's not the only one also, you know, somebody could speak up. We did do this last time. We did a few of these.
Mm-hmm. So if that
So underneath the minus 36,000, we would put the 2070.
That's right,
Mhm.
2070. Because we have to have the standard deviation for the brand B tires, and it says brand B has a standard deviation of 2070 or whatever, right? Good.
Mhm. Mhm.
Alright, so what do we put here then?
The 4,200. 34, is it 3,400?
1,000 miles.
34,000.
Uh-huh.
34,000, this one.
Uh-huh.
Because it says that because we want to compare how much, you know, I mean, when they say he's 36,000 miles, the tire goes, right? If someone drives the car very, very, very slowly all the time and doesn't turn very much and all this for whatever reason, you know, they're gonna drive more miles, you know, versus someone who's turning and weaving and doing all these things all the time. They're gonna drive less miles on the same tires. So, because the tire's gonna wear out a little faster. So this, we're comparing the number of miles that she drove, 34,000 to 36,000, because 36,000 is the average here, right? Does that make sense? Guys?
Yeah, it makes sense.
Yes.
Yes.
Alright, so then here, we gotta calculate this, so we get about that, so what is this, 200 divided by 207 approximately? So 0.9662. Alright, now. We got this number here and this number here. And they wanna know now Within their brands, which of the two drivers got the better wear? Okay. What would you say? And why, obviously. Oh, excuse me, this should be negative. Which would you say is better? Nicole or Yvette? Is this one saying she's a little less than one standard deviation? Less than the mean? Or excuse me, a little more than one standard deviation, less than the mean. And this one is a little less than one standard deviation, less than the mean. So which one, who did better? With respect to the wear of their tires? Hello,
Yvette,
Yvette, yes.
Uh-huh.
So why did Yvette do better? Because she, compared to the other people that drove the car, she wore the tires a little bit less than what this person wore the tires. So therefore she drove a little slightly better. All right. Any question with this? Is it okay here?
Yes.
Yes.
yep.
All right, percentile now. So percentile. All this is that we need to do the number of values less than, let's say X divided by the total number of values. And that shouldn't be too crazy of a thing because we've said for a million times, the percentage is really just the number divided by the total. So now the only thing is in this case that we have to remember is it's going to be the number less than. Okay. So sometimes people also call these things order statistics. Because you sort of have to line all the numbers up. And then you say like, oh, which one, what's this one? Well, we count the number of numbers less than it. And then we say, oh, well, that's 6 out of 10. So this is the 60th percentile. It has 60% of the data less than it. Does that make sense? So we always have tests and people will say, I got in the 88th percentile. This doesn't mean they got 88% correct. This means they scored higher than 88% of all test takers. All right, so they want us to know what this means. we need to understand for lots of different reasons, honestly. But they're gonna give you a few questions that you need to be able to answer. Some of them are gonna ask, what is the percentile of the particular data value? And then the other things are gonna ask, here's the percentile, which data value is associated with that percentile, given some data set. So following are the number of dinner customers served by a restaurant on 40 consecutive days. The number of them range from least to greatest. Find the 65th percentile. Excuse me. So there's something here that there's one place where I guess it's easy to make a little bit of an error or confusion. So let's just talk about that first. So let's just say you have a data set and it's like x1, x2, x3, x4, and x5. There's like these other numbers that are between these numbers here. And these numbers between these numbers are also possible values that we're allowed to assign as percentiles. So we're allowed to pick some data value that's actually in the data set. We're also allowed to pick data values that are between any two values, consecutive values in a data set. So where, I mean, like x 1.5 is the average of x1 and x2. And we've already done stuff like this. Like we said that if you have, 4 numbers, and then I was to calculate the median of this, we said that the median would have to be like between these two. And we said that we're going to do 2 plus 4 divided by 2, or we're going to get 6 divided by 2 is 3. So 3 is not obviously in the data set that I just made up just now, 1, 2, 4, and 7. So, but yet it's still the median. So it's the same thing sort of with these things. There's going to be these numbers that are in the data set that we can end up getting, but then there's also going to be these numbers that are sort of between two numbers in the data set, and we're also going to be able to get those. All right. So we got to pick which one of those sort of is the best answer for the question. In other words, which one of the numbers has the right percentage of the values less than it. Okay. Do you guys understand what I mean so far?
Yes.
All right, find the 65th percentile now, it says. All right, so would anybody have any idea how to start? Oh yeah, sometimes also people denote this by saying P65. They'll say something like that. That's another way to write the same question. Does anybody have any idea how to start this if I say 65th percentile?
Will we put them in order, or are they already, okay, wait, they're already in order.
We would put them in order, that's correct, but they're already in order.
So then I guess we just count.
Count
do we-
what? How? That's correct. Yeah, pretty much. But how?
So we would start off 46 and then count all the way to 88, and then
Well,
guess.
they said there's 40 of them.
okay, 40. So we already know 40. So I guess we got to find what's 65% of 40.
Very good. Okay, so then that's all we really need to do is we need to determine first what 65% of 40 is. So then that's going to be what? 0.65 times 40. 0.65 is the same thing as 13 over 20. 13 over 20 times 40, so that's just 2. So we get 26. So what do I do with this now? 26.
So then we count to 26.
Hold on one second, I apologize. Alright, sorry. So what do I do with the 26, sorry?
So we count up to the 26th number.
Count up to the 26 number. Okay, so let's do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I think I got this one. If I'm correct, there should be 14 numbers remaining. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Luba, it's in the attic in the garage. In the attic in the garage. In the attic. And there's a light right there. So what do I do with the 26? What do I do with 67? Is that the answer?
What that would be
There's a
the
light, there's a light in the attic. That would be the answer?
No,
no.
What? Why not?
put 14 over 67, I think.
14 over 67? Say
Yeah.
it.
Isn't that what you did for the first one with the leftover? You put it over the number.
What does the 26 mean first?
Uh, 26. This is just the number. Well, that would be the rank. Like that's like the 26 most customers out of the 40 days.
Sort of. I mean, percentile is supposed to say, we just said is like the number divided by the total, right? So then what did we just do? We just did the percentage times the total. So this is the number.
Hmm.
But it's a number less than, right? So there should be 26 values less than P65. Does that make sense?
Okay.
So 67 can't be the answer because it doesn't have 26 numbers less than it, it's 25 numbers less than it, right?
Right. Right.
Okay. So what should the answer be then?
The one after.
So you would think then that you should pick this one, but that would be incorrect also.
Oh,
There's a slightly better answer. Okay,
in between. Is it
yes,
like
the one in between these two right here. So if we say 26 numbers have to be less than our number, we effectively need to, so our choices are, we could do like X, let's say 25. We could do X 25.5. We could do X 26. We could do X 26.5. We could do X 27. Does that make sense?
yes?
So then the question is that if we need 26 numbers less than us, then we should pick that one. Does that make sense?
That makes sense.
I got you.
So you got to round up to the nearest number divisible by 0.5. If that makes sense. Okay. round up to the nearest sort of like thing with the 0.5. So either it could be like this one, or it could be this one, or it could be this one. In this case, it's this one. All right. So we should say then the answer is 67.5, the number between these two. Luba? Can you just go and make sure that he's like actually in the attic? Does that make sense? Does it make sense, guys?
Yes.
Yeah, it makes sense. It makes sense.
Alright, so how would I do
Yeah,
88th
yeah.
percentile then? Tell me how to do this one.
So first you'll have to start, you have to find out what's the 88% of 40, right?
That's correct. So then that's just gonna be 0.88 times 40. What is that? 25, so that's 3 is 22 over 25 times 40. I don't know if I want to do this one in my head.
It's
Wow.
35.2.
35.2. Thank you.
Yes.
35.2. All right, so 35.2. So what are we gonna do with this now? What does the 35.2 mean again now?
So now we have to find the number that's the 35th rank.
I'm gonna find the number that's 35th rank. Very good. So then this is what, 40, 39, 38, 37, 36, 35. So this one I think is the 35th. value.
72.
72 is not the final answer though. 72 is the 35th
Okay, I
value.
got you.
So what are we gonna do? What if? So now 35.2, what does this number mean? Just like, what did this number mean over here? What does 35.2 mean?
It means the 35th most customers out of the 40 days.
It means 35.2 need to be less than me. Does that make sense?
Okay, less. Yeah, less. Right.
It's
right.
the less than part that you gotta make sure you remember when it comes to percentile. So 35.2 need to be less than. So 35.2 numbers less than P 88. Okay, all right. So now again, we have the same question we need to ask. So if we have the 35th number, this one, which one's gonna be the answer?
Would that be 35.5?
Yep. Because we didn't round up to the nearest 0.5. So in this case, if we have, it's sort of like saying like, if you only got like quarters and you gotta go pay, right? What would you need to go pay? Right? If you had a 35 point, if it costs $35 and 20 cents, then you would need to have, I guess, $35 and well, actually, I guess I shouldn't say quarters. I guess I should say $50, $35.50. And then you'd have enough money to pay. All right. That's sort of the way you should think about it. Okay. All right, but that would be correct. So then in this case, we
So
should
you just round?
round up to the nearest like half. So if
Oh,
it's,
okay.
if you get like 35.2, you round up to 35.5. If you get 35.6, you round up to 36. If you get 36.1, you round up to 36.5, etc.
Got you.
So in this case here, we need to find the number between these two right here. So that's 72 plus 75 divided by 2. So that's 3. So that's 73.5. Hold on one second. please.
Okay, I'm with you. Wait.
Luba, what's the matter?
Yeah, I'm with you. I had some just now.
Okay.
You good?
All right, that's fine. No, a little bit, yeah.
You need at least 125.
Free on floor.
150. That's a 14 a unit. You see you at 110. What's gonna happen? The thing is, the reason it doesn't freeze up right now is the fact that it's not hot. You know, it's raining and everything. But when the hot season kicks on, it's gonna be freezing up.
So how much would it be to, so
That's about like 2 to 3.
how much does it cost, I mean?
The first pound is 275. Any additional is
$275 for a Freon?
Tell you where the company, the thing is on the tablet. You know what I mean? It's not me. But I would think out the cost on it. But I can go to, you know what I mean? So because it's on the tablet, you know? The only, since it's about like 2 to 3 pounds, I can put like, if it's 4 pounds, I can say I just put 2 pounds. That's the only way I can save you. But otherwise, I cannot say anything. I cannot change anything. That means the unit that are like 3 pounds, I can say I sell 2 pounds. That's the only thing. The only because I know how much the current.
So you told me it's gonna be like $550?
No. 275.
375?
Yeah, it's the fact that I don't charge you 3 weeks. I'm telling you. If not, when I come into your house, I'm doing something on the side. It's a different story. Company, they can just like
That's crazy.
yeah, you know. But honestly, friend costs money. You know that?
Yeah.
The tank comes $700.
Okay,
The tank. Yeah.
sorry.
Yeah.
All right, so then the,
Are you doing this now?
Yes.
Okay.
so then,
No.
Okay.
and just check the, just make sure you clean the drain. Run, no, if you can you do it from the top? Can you just put the drain solve in the top?
It's not always a good idea. It's always better to suck it outside. If
Yeah, I
it's
know,
only
but
with
it doesn't-
natural, okay, you can push it out.
Yeah, it's too long though, that's the problem. It's way too long.
And that's the best way to make sure because the hatches and stuff coming out. If you're using nitro, especially I don't have nitro, I use mostly the vacuum. It's the best option. Sometimes when you put too much pressure with the nitro, it can even, you know, disconnect the PVC somewhere in the middle of the night.
No, I mean like, drain solve, like the liquid.
Oh, you're talking about the liquid.
Yeah, I'm just saying, can you put the liquid in the top and then, when you,
You have bleach, that's the bleach. They mostly use.
the bleach, yeah, but the bleach makes the,
The thing you're talking about, I don't know. Yeah, so I'm gonna suck, but the thing is, your nice clean, right? It's not like wow, it's okay. And I check the clothes and everything is okay. So
Okay.
when I'm sitting down, start stuff.
okay,
Yeah, you know, but for the guys.
Okay.
And I see water coming out. That's the one where you can see that.
I'm gonna keep the doors.
all right, sorry.
Okay.
So deciles and quartiles. So these are just like, this is kind of nothing really. This is not really like too much more or anything like that. This is just a, another form of percentiles really. So like, for instance, if I say to you, you know, P50, this is the 50th percentile. This is the same thing as the median value, because it has 50% less than it, 50% greater than it. And this is also the same thing as we say the second quartile. And we also call this the fifth decile. So for instance, D1 is equal to P10. D2 is equal to P20. D3 is equal to P30, etc. So D5 is equal to P50. All right? And this, you know, so these are just different names for things. So then what they say is these are called deciles. And there's, you know, 9 of these, I guess. Then there's also quartiles. Quartiles means if we took the data set and we broke it up into 4 quarters, then there would be Q1, Q2, and Q3, where Q1 is greater than the first 25% of the data. Then Q2 is greater than the first 50% of the data, and Q3 is greater than the first 75% of the data. So in other words, Q1 is the same thing as P25. Q2 is the same thing as P50. And Q3 is the same thing as P75. Does that make sense?
Yes.
So these are actually pretty easy to find here. So if it says find the first 3 quartiles for the data. Since the data set's already organized and it's already sort of broken up into quarters here, you know, if we just split it like this, and then we took the first half here and split that, and then do the same thing with the second half here. Then the numbers that's dividing these sections here is effectively going to be the values that we can define for the quartiles. So in other words, Q1 should be the value right there. It's sort of like after 59. Q2 should be after 65, and Q3 should be after 69. Now, I'm going to write this out also, just to explain why that rounding thing we had to do before has to happen. But you know, it should be fairly easy to see what these values are in this case. All right, so Q1 is going to be 59.5. Q2 is 65.5. Q3 is 69.5. All right, so let's just calculate, let's say Q3. So Q3 is the same thing as P75. So P75, in this case, there's, I don't know how many numbers are here, 4, 5, 40. So there's 40 values here. So 75% of 40 is 30. So 30 numbers, this is the 30th number right here. So if it's the 30th value and we have 30 numbers that need to be less than our number, then we need to round up a little bit here. So we round up to the 30.5th number. So therefore, P75 based off what we did previously here needs to be equal to, what is this? 69 plus 70 divided by 2, or we get 69.5. All right, why does this have to be the number, and why can it not be, let's say 69, or why can it not be 70? All right, so 69.5 is the value right like here, after 69 but before 70. The how many values are less than 69.5? So 30 values are less than it. And how many are greater than it? Well, I guess all of these, that's 10. Alright? So. If we have this situation, 30 are less than and 10 are greater, then that's exactly 3/4 less than and 1/4 greater than. So that's the best answer for P75 here. Alright? So if we chose 69, 69 has only 29 values less than it. 70 has only 9 values greater than it, etc. Does that make sense?
Yes.
Alright, a box plot. So all a box plot is that like, you know, whatever, so there's this thing called the 5-number summary. So the 5-number summary is the minimum data value, Q1, Q2, Q3, and then the maximum data value. Alright? This is sort of like a description of what the data set is. So let me just give you an example. Here's some box plot. So it says allele, and then, I don't know, I can't read this, but value, I think it says. So these are these two different types of, two different genes here. And they're comparing some value associated with those two different genes. And they're having these distributions. The, the distribution associated with the different alleles, the first one, is, you know, they're trying to describe it based off this box thing. So this right here is the minimum value. That's Q1, that's Q2, that's Q3, and this is the maximum data value. And then likewise, this is the minimum, this is the Q1, this is Q2 or the median, this is Q3, and then this is the maximum value for these things. And you know, from this, we can see that there's like a fairly reasonable overlap between the two data sets here in their values. Most of these values here, though, are almost larger than 75% of the other ones. Like 75% of these values are approximately larger than 75% of these values. But this kind of gives you an idea of what's going on with the data set. Does that make sense? So they might ask you to interpret a box plot. They might ask you to make a box plot. All you'd have to do is be able to figure out what these numbers are and then label the box plot. Any question?
No, sir.
All right. That shouldn't be too bad, actually. All right, so this next bit is sort of the main thing that's left, all right? Completed ones for this. Interesting. Okay, I guess I just didn't write it on here at all. Interesting. All right, let's just do it again, who cares? All right, so they want you to know about some particular distribution called normal distribution. Normal distribution, if you were to make a histogram, the histogram would follow some sort of shape, like the following. So maybe there would be like a bar here, let's say, a bar there, a bar there, a bar there. Maybe something like this, okay? And it would follow some sort of shape, generally like that. All right, if something follows this shape where it has like, the highest frequency in the center, and then it's symmetric, and then it has decreasing frequencies. Going in these directions here. Sorry,
Oh, I think that's good.
hold on one second, I apologize. What's up?
No, I was gonna, when I'm done. So I charge it to. What is it? If you are busy. Yeah. Okay.
All right, so they need you to be able to kind of understand something about this distribution, because the reason being is like the equation associated with it is a little crazy.
Professor,
Yeah.
good evening.
Okay, now?
Just
Hello?
letting you know Simone is present here.
Hi. But I always do the.
I'm seeing where I'm
attendance.
absent. I'm
Oh,
seeing where I'm being absent now.
Yeah, I always do the attendance at the beginning though. It doesn't matter though, the absent or not. It doesn't count for the grade.
Because actually I went to class. I went there and that's when I checked the message and saw,
Oh.
so I came back home and joined the,
Sorry about
via
that.
my whole app. Yeah, that's okay.
The,
Okay.
but the equation here is, fair, oh. God. The equation here is fairly, confusing. Let me see if I can just copy it here so I can make it a little bigger. This thing, it's not the simplest really equation. And then the shape of the graph is this shape right here. Luba, could you close the door? So the thing is that the portion of this graph that ends up being important to us so sometimes people call this graph the standard normal distribution. And sometimes they'll call it Z. So when you calculate Z-score, this is really the same Z. If X is normally distributed, or follows this particular shape, then Z is normal, or we say standard normal, with mean equal to 0 and standard deviation equal to 1. We use these variables though. All right, this is the Greek letter sigma for standard deviation, and then this is mu. I think we talked about this one already for mean. These things here, so in other words, this means Z is equal to 1, Z is equal to 2, Z is equal to 3. Here is Z is equal to 0, Z is negative 1, Z is negative 2, etc. The thing that matters for this thing though is like the area underneath the curve between particular places. So from here to here, this is they want you to know something about this area. So this area here, from here to here, it turns out it's approximately equal to about 68% of the data. Then this area here is approximately equal to 95% of the data. So 95% of the data, just to restate this, 95% of the data following this distribution is within 2 standard deviations of the mean. Now, if you go 3 standard deviations, so we include up to 3 and -3. So if we say, what's the probability that some normal random variable is within 3 standard deviations of the mean? Then this, it turns out, is equal to approximately 99.7% of the data. Now, if you don't know these numbers about this distribution, you kind of have no idea what the shape means at all, because there's no way you can calculate these things without pretty good calculator, honestly. And it's so I always liken it to this. If I ask you what's square root of 9, what's the answer?
3.
If I say what's square root of 4, what's the answer?
2.
2.
2. And then if I said to you, what's square root of 7, but you're not allowed to use a calculator, and if you don't get it right, you fail. I would think most people actually would not know how to do that. And the only thing that I would expect, honestly, most people to be able to tell me is that, well, this is gonna have to be a number between,
Is it 3.5?
not exactly, because like 3.5
It's
squared
2-1.
is too big, okay? But the
Oh, okay.
the thing, it's 2 something is correct.
2-1.
2-1, 21.
Yes. No, 2, and then I think you'd have the square root with 1. I think that's how it's written, with the 2 and then the square root over 1, something of the sort, the sign over 1.
You would need, so like, what is this? You gotta think of a number that's close by 7, that this, you could square, that gives you something like 7. So like, 20 squared is like 400. Okay, 25 squared is 625. 26 squared is, I think 676. So I think it's gonna have to be close to this, because 27 squared is 729. So I would guess somewhere like 26.3, something like that. Or 2.63, something like this. So I don't know what the answer is though, but that's not really my point. The 2.64 or whatever, but I was close. But I mean, I can show you a way you can calculate it and it can give you the exact answer. But it just, you keep going and going and going, though. It takes forever. But the point is that I wouldn't really expect a person to be able to do very much with this and be able to say very much with this without a calculator, except for the fact that I would expect them to be able to tell me it's going to be somewhere between 2 and 3. And that's sort of the same thing with this thing. So this rule that we're talking about right now is referred to as the empirical rule. Empirical means like coming from experimentation or observation. So the empirical rule, sometimes people also call it the 68, 95, 99.7 rule. This is the 1 standard deviation, 2 standard deviation, 3 standard deviation rule. That 68% of the data will fall within 1 standard deviation, 95% will fall within 2 standard deviations, 99.7% approximately will fall in 3 standard deviations if the distribution is normal. And it turns out a lot of things end up being normally distributed, so that's why they end up wanting us to know something about this. Okay? Do you get what I mean by this 68, 95, 99.7 thing so far?
Kinda.
All right. Now, there's a chart that I'm going to want you to use on your exam. So we got to talk about this chart a little bit and how we use it. So this chart is posted online on D2L. All right. It says standard normal probabilities. It says table entry for Z is the area under the standard normal curve to the left of Z. And then it starts giving you this picture here. And it gives you all these numbers, which we'll talk about what this means. And then it continues and it says the same thing. Table entry for this is to the left of Z here. So I always make a joke that like Beyonce wrote this table, because everything is to the left. But this, to the left here, they start giving all these positive numbers here, and they start giving these answers. All right, so we need to explain how we use this table. So for instance, oops. Where did it go? I was ready. All right, sorry. So when we were doing this, I had this curve and I'm claiming this thing about the area. 68%, 95%, 99.7%. And I just want to show you here that on this calculator, so we don't know, this is not that easy to do. But if I tell the calculator to determine the area between, like, let's say -1 to 1 of this thing. And that means that I'm trying to find this particular area here. All right. So if I want to find this area, turns out there's this thing you can do to find it, but it's hard for this question. So we don't want to even try that. And this, it tells me here when I do this, that the area ends up being about 68.27%. So they don't say 68.27, they just say, remember 68. But this is the area. Now, let's say we wanted to do 2 standard deviations. Well, this, it turns out, is 95.45%. All right, a little bit more. And then if we go 3 standard deviations, we end up getting 99.73%. So they say, remember 68, 95, 99.7. All right. Then here, this. So we can use this table to get those answers. All right. So let's say I wanted to find the, let's first just try and actually just explain the general idea about how I want to do this. And then afterwards, we'll do it with this example. Okay. So what there's always going to be is there's going to be like some lower value and some upper value. And then we're going to have to find the area between those two things. The way we do this, though, is we find the area of this part first. We find the area, because this is the way the table works. We find the area of that part. And then we effectively subtract those two things to find out what the area is of the portion that we wanted. All right, so let's say we call this one C. Let's say we call this one A, and let's say we call this one B. Effectively, what we're going to do is we're going to do C minus A is equal to B. Does it make sense? Do you understand what I'm saying?
Yes.
All right. So then here, you gotta understand how to read this table though, which is a little confusing. So to determine, let's say we wanted to do the question that I was just asking before. Let's say I wanted to do -1 to 1. All right, so let's say I asked you, what's the probability that if something was normally distributed, that the value would be within 1 standard deviation of the mean? All right. Now, the answer we know is approximately, we said 68%. Let's see if we can calculate that
Okay.
based off. Question?
No, I'm agreeing with you.
Now, let's see if we can calculate that using the table thing. All right. So first, there's some lower value and there's some upper value that we need to look at here. So this is the lower and this is the upper in this case. So we look both those numbers up on the table. All right. So I need to look up -1 and 1. Do you see here it says Z? And then it has a bunch of negative numbers here. And then you go down and then it says Z. And then there's a bunch of positive numbers. So we need
So what
one.
does Z represent?
Z is the number of standard deviations away from the mean. That's what we said last
Okay.
time. And that's what we said at the beginning. So then this thing here, this, remember we did this formula, Z is equal to X minus the mean divided by the standard deviation. This formula we said was Z score. Z is the number of standard deviations away from the mean. All right. So then if we have 1 standard deviation away from the mean, so here's 1 right here. 1.0. So if you wanted to be 1.00 standard deviations away from the mean, then it's telling you to use that number right there. If you wanted to move it a little bit further over and it needed to be 1.01, then that would be this number. 1.02 would be this number, 1.03 would be this number, 1.04 would be this number, 1.05 would be this number, etc. That would be defining the area to the left of this point right here. Does that make sense?
Yes.
So about 84.13% of the data is to the left of 1 standard deviation to the right of the mean. So here, this value right here, the area there, we say is 0.8413. All of this to the left there, about 84% of the total thing, okay? Then now we need to look up though, this value here, which is -1. So I go to the negatives and I do the same thing. Oops. So -1 is like right here somewhere. And then you see it says 0, 1, 2, 3, 4, 5, whatever. So now this is going to be like -1.00, -1.01, -1.02, -1.03, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. All right. So in other words, -1.00 would be this number right here. 1 second. Program just died. All right, let's try that again. So we were here, -1.0, -1.00 is this value right here, 0.1587. So then it's saying that this area right here is about 0.1587. So now if I wanted to determine this area, then that would be, I guess, I would do 0.8413 minus 0.1587. And then we would end up getting what, 13 minus 7 is 6, 10 minus 8 is 2. Versus 13 minus 8 is 13 minus 5 is 8, and then 7 minus 1 is 6. So then we get that the answer is going to be approximately equal to 68.26 percent. And if you recall from before here, if we did this thing here and I make E equal to 1, you see this number here. I don't know if you can see this, but this value is the same number more or less. All right. To 3 decimal places. Any questions so far? So that's pretty much all you're gonna have to do every single time is look up these numbers on the table and then determine what this answer is going to be. So you're gonna have to find the area, the one for the upper number and then the lower number, and then you just find the difference between those two values after you look them up. Program just tweaked out again. All right, so let's try some of these questions. All right, suppose that 300 chemistry students take a midterm exam and the distribution of their scores can be treated as normal. Find the number of scores following in each of the intervals within 1 standard deviation of the mean. What would you say? How would I do this one? Find the number of scores.
So so anything less than 1 standard deviation, that's anything less than like 68 point whatever percent it was.
Well, be careful the way you're saying it. So like 1 standard deviation away from the mean. This was approximately 68% of the data, this area. If the total area is 1, then this part is like 0.68. So what this is saying then is 68% of the scores would fall within 1 standard deviation. Approximately. But what would the number of scores be? How would I figure out the number then?
Well, then would I just do 68% of 300?
That's correct.
Oh,
So 0.68 times 300. So that's the same thing as 68 times 3. So that's 210 minus, that's 204. Does that make sense?
yes.
All right. So then the next one's similar. The only difference is that now we're saying that we're a little further out. So, and I do suggest to draw these pictures each time when you're doing these questions. It does help. So, how would you do this one?
That one's 95.
That's correct. So it was 68, 95, 99.7. Well, I guess the answer is not 95 though. What do we do?
We do 95% of 300.
That's correct. This area here is about 95% of the total area. So 95% of 300 is, what is that? 515 is 285, I guess. About 285 people are within 2 standard deviations of the mean, if it's normally distributed, and there's 300 people. Any question? Okay. Suppose 120 geology students students measure the mass of an ore sample. Due to human error and limitations in the reliability of the balance, not all readings are equal. The results are found to closely approximate a normal curve with mean 86 grams and standard deviation 3 grams. Use the symmetry of the normal curve and the empirical rules needed to estimate the students reporting readings between 77 and 95. All right, I'll do this one for us. This one's pretty easy. The only thing is that it's very hard if you don't remember to draw the normal distribution. Okay, so just try and sketch some little normal distribution. And then over here, that's the mean. So the mean in this case, always label whatever the mean is. The mean here is 86. And the standard deviation is 3. So then just start adding and subtracting the standard deviation. Dude, what's up with this program today? All right, so just start adding and subtracting the standard deviation. So 1 standard deviation, let's say, is about like there away. And then 2, let's say, is here. And then 3 is somewhere over here, I guess. All right, so 1 standard deviation, if I add 1 standard deviation, I guess this would be 89. Add 3 again, 92. Add 3 again, 95. Subtract 3, you would get 83. Subtract 3, 80. Subtract 3 again, 77. So then because this thing just keeps going on and on and on and on forever in either of these directions. So now they want us to know, what is this area here. Well, this is how many standard deviations away? This is 1, 2, 3, 1, 2, 3 standard deviations away in either direction. So therefore, this is within 3. So it's 68, 95, 99.7. So if there's 120 people, then all we need to do is 99.7% of 120, which is This is 119.64. Which of course would round up to 120. So we would expect more or less everybody to have readings between, or every value to be have a value between 77 and 95. Any question?
No.
No.
All right. This one's slightly different. All right. Assume that a normal distribution has data of mean of 11 and a standard deviation of 2. Use the empirical rule to find the percentage of values that lie below 9. Again, though, what we need to do is start drawing normal distribution. Center of the normal distribution needs to be the mean. And then start adding and subtracting the standard deviation. So if I add it, I get 13. Subtract it, I get 9. Add it, I get 15. Add it, I get 17. Subtract 7, subtract 5. It says find the values in this case that are below 9. So it wants to know this part here. Any idea how you do this? Anyone have a suggestion? Well, what they want us to do is they want us to use the empirical rule. So within one standard deviation, we know is 68%. If there's 68% within one standard deviation, and this thing is symmetric, then that means that whatever's on this side here and whatever's on that side over there need to be the exact same thing. So since the total is 100%, there's got to be 32% left over here and here combined. In other words, each one of these needs to be approximately 16%. So this one needs to be approximately 16%, and this one needs to be approximately 16%. But they start talking about doing this with the Z table, so we might as well just do that also. So let's talk about how you can do like all of them. And if you just keep doing it this way, you really should be able to get all these correct. So the mean is 11. Nine is obviously less than 11. The standard deviation is 2. Another way to do this is to just use the table that I was giving you before and just use the Z-score to figure this out. So in other words, all you do is calculate the Z-score of this position. So we recall the formula. Z is equal to X minus the mean divided by the standard deviation. So X in this case is 9. The mean is 11. Standard deviation is 2. So this is -7/2. Whoops. If you know how to subtract this, it's not what this is at all. This is -2/2. That's -1. All right. So in other words, we could just say that this is the same thing as saying that Z here is -1. And we need to find the area to the left of -1. But that's exactly what the table already tells us. So this table, if you give it the Z value here, it tells you the area to the left of that. So in this case, we already looked up -1 before, actually. It's 0.1587. So that means that area right there is approximately equal to 0.1587. And that's it. Now, when we did it this way, we got an approximation, 16%. This is a slightly better approximation. Question with this so far?
No.
No.
You get what I mean? How to calculate Z-score and then how to look it up on the table?
Yes.
Yeah.
All right, we gotta do some more examples though. All right, so now it wants to know this area right here. The purple area right there. The Z right there is 1.16. How are we gonna find this area here? using the table?
The chart,
How? Yeah,
we look at what it corresponds to, on the chart.
so what do I look up on the chart?
So 1.16.
And then that's it? That's the answer?
I would think that's the answer.
If I look up 1.16 here, right? It's gonna tell me this area, right? That's not the area they said right here. It doesn't want me to find all of this. Does that make sense? It only
Okay.
wants the purple part. You got me?
Yeah.
Alright, but we do need to look up 1.16. Alright, so what would the value be for 1.16 here?
Oh,
8554.
Nope.
877.
877 is correct. 1.1 here. And then 0.06. So then where do those intersect? This thing, 0.8770.
Mhm.
Does that make sense? Is that okay?
Yes,
Alright, so then this red area here is 0.8770. Now, we have to subtract though this part. Right? Well, we can look up this number on the table then. 0. So if we look up 0 on the table, we get 50%. Now, I guess that part should have been kind of obvious, actually. We didn't really need to look it up on the table, I guess, because if this thing is symmetric, then there would have to be 50% on this side and 50% on that side. So 0 is where it's going to be symmetric. So we need to just subtract 50% from this. So we get about 37.70%. Do you guys get what I mean though? Where like there's a bigger area and the smaller area and you just subtract?
Yes.
yes.
Yeah.
Any questions so far?
No question.
So this means that 37.7% of the data will lie between the mean and z is equal to 1.16. When z is equal to negative 1.16, what is the a value? I don't know what they mean by a value necessarily, but I think what they mean is if we had negative 1.16 over here, and they want to know what that is right there, what would that area have to be? Because we just did this one over here, and we got 37.70%. What would that one have to be?
Would it be the same?
Yep. Because
think so.
it's symmetric, right? So this would have to be 37.70% also. Any question so far? Again, though, I sincerely believe that it's helpful, extremely helpful, to draw these pictures. Okay, so please draw the pictures. Otherwise, you're gonna have a problem. Alright. So this one says. Between. Negative 1.2. And 2.62. This one says. To the left of 2.34. This one says. To the right of 1.30. And make sure you can label these things properly. 1.1. 2.4. Negative 2.6. And negative 1.25. Alright, how would you say, how would I do the first one? Using the table.
We just find the number that's between minus 1.20 and 2.62, and then look at. Whoa. Hello?
And look at, I don't know what you mean, though. Find the number between them and look at what, I don't know
Yeah,
what you mean.
I cut out for a second. Then look, and then once we find the number, we look at it on the chart.
What number? I don't know what you're talking about.
No, for A. I'm saying
Yeah. Yeah, what number do you mean? We look at, what number
So-
between?
between minus 1.20.
So what number? What are you talking about?
So whatever, well, we would find the number. I'm saying whatever that number is.
So what do we look up on the table?
We will, well, we wouldn't look, we have to find it first and then look it up on the table.
So find what? I don't know what you're talking about.
Okay.
'Cause
So,
I mean, we don't have to find anything. We already know what the numbers are here and here.
Do we look up the values for each one and then subtract them from each other?
That's correct.
Okay.
So all we want to do is we look up 2.62 on the table and negative 1.2 on the table, and then we need to subtract those two values, is correct.
all right,
So
that's what I was thinking.
that's what, okay, you just didn't say it that way. Okay, so that's what, honestly, that's why I was just asking you, like, what do I do on the table? Because I
Yeah.
think you were gonna tell me the right thing. But, all right, so 2.62, so what's 2.62 here?
0.9956.
That's correct. This is 2.60, this is 2.61, this is 2.62. So we get 9956. So we do 9956. And then we need to subtract whatever that part is right there. So we need to look up negative 1.2. All right, what would that be?
Point 1151.
1151 is correct. 1151, so we get 8805. So this one's approximately equal to about 88%. So 88.05 Alright. This one's actually pretty easy, 2.34, because it's already saying to the left here. And that's what the table gives you already. So all I really need to do is just look up 2.34. So 2.3, 0, 1, 2, 3, and then this one, I guess, would be 4. So 99.04 or 99.04%. All right. How would I do this one? Let's see. Because I know we can look up 1.3 on the table. That's not really that hard. 1.3. Okay, great. We get this number. 0.9032. But that area right here is not 0.9032. It's not 90%. So what do I do with this?
Subtract
Subtract from what?
the total.
Which would be,
Uh,
how about 100%? How about 1?
yeah, that sounds good.
Okay, like the whole thing is 100%. So if you're talking about 90%, if 90% is really this part here, right? Then the whole thing is 100%. All I do is 100% minus the 90%.
This is making so much sense, sir.
It is
Yeah,
9 minus 3 is 6. And this is, well, that's good because if you have to take the other statistics class, which honestly every single person in here should have to do, we're going through chapter 6 right now in that class. So you should be able to do just fine. So I get about 9.68% for this one. Any question? Is everyone okay with that?
Yes.
Yeah.
All right, tell me what we would do for the next one here, D.
Would it be
You
this?
look up the value of 1.1 and 2.4 minus the values. Is it the same as A?
Pretty much, that's correct. So, I mean, that's all. We just look up 1.1 and look up 2.4 and then find the difference between the two values in the areas, and then it has to be the correct answer. So that's perfect. 2.4 gives us 0.9918. So we have 0.9918. And then 1.10. What's 1.10?
1.10 would be 0.8643.
That's correct. 0.8643. So again, please make sure you have this printed out when you do your test. All right, guys? All right, you definitely need this thing. So 11 minus 4 is what? 7. 9 is 8 is 2. And then 1. So I guess we get that this one's approximately
12.75.
Yep, percent. All right. Okay, so far?
Yep.
All right, what about E? How would you do E?
We would look at both numbers on the chart,
And then what?
and then we would subtract.
Yep. Pretty much every time, that's all you ever do. So that's why this is kind of a good way to deal with this stuff. So minus 2.6 is 0.0047. Minus 1.25 is, what's 1.25?
That's 0.1056.
That's correct. So. One, two, five, right? So we have 1, 2, then this is 0, 1, 2, 3, 4, 5. So we get 1056. So 1056 less 0047. So 56 minus 47 is what? 9. So we get 0.10009.
9.
So then this is about 10.09%.
10.09%.
That's correct. Any question? All right. All right, we gotta do a couple more of these though, because now there's gonna be some where they're gonna give it to you in a word problem format. And really, the only difference is now it's sort of like one of the ones we did at the beginning where we have to calculate the Z-score. All right. So an IQ company normally employs workers whose IQ scores are normally distributed with a mean of 110. So the minute they start telling you anything where they start saying normal, just start drawing the distribution. All right. The mean is 110. Standard deviation is 7.5. Management uses this information to assign employee projects that will be challenging but not too challenging. What percentage of the employees will have IQs less than 104? All right, 104. So 110, I don't know where 104 is, but let's say it's somewhere over here. They said, what's the chances your IQ score is less than 104? Now, the way we need to do that again is we need to calculate the Z-score for that particular position. So the Z-score for position 104 is going to be equal to, do you remember how to calculate that? How would I calculate the Z-score for that thing? What would you say? Hello?
It's me.
What do we do? How do we calculate it?
It was a joke, Mom.
She's gonna beat you up.
I am paying attention to my class, Mom.
What are we gonna do?
X minus the mean over the deviation.
That's correct. X minus the mean divided by the standard deviation. So what are those values? What do I write? What do I write for the mean?
110.
Yep, I mean, it says it right there, so that part should be easy. 110. What's the standard deviation?
7.5.
Says that also, so that should be easy. 7.5. What's X? 104, because that's the number we're actually interested
104, you're
in.
right.
Because we need to find how many standard deviations that is away from the mean, right? So then this is going to be what? -6 divided by 7.5. So it's the same thing as -60 over 75. It's the same thing as -12 over 15. 3 goes into each of these things, so that's -4 over 5. So we end up getting -0.8. So that means this position is equivalent to saying that the number of standard deviations it is away from the mean is about a little less than 1 to the left. All right, if I know that, then I can use that to figure out what the area is by just looking that up on the chart. So then I just look up what is negative 0.8 on the chart, and we get that this is gonna be equal to 21.19%. Do you understand?
Yeah, it's a
Yeah.
little.
Any questions so far?
Can you go over the last part one more time, please?
So,
Just the last part.
so if you have that, you know now that this position right here is minus 0.8 standard deviations away from the mean, then the table
Right.
here tells us on the table that if you tell it what Z is here, it'll tell you the area to the left of that. So in our case, we have Z is equal to negative 0.8. So negative 0.8, I start looking that up on the table. I get to there. This is negative 0.80 right here. So then that was the number I looked up, and then that was it. I just said that that was the answer.
Got you. Okay, now I understand it. Thanks.
The average length of fish caught in Vernell Lake is 11.4 with standard deviation 3.8. And the probability that fish there will be caught between these two things. What am I gonna do? How am I gonna do this one?
You just gotta divide, right?
What do you mean?
Hold on. Or standard deviation.
We would do the formula for the Z-score
For what?
for well, because we have the average length and we have the standard deviation. And
That's
then
correct.
So do we find the Z-score for both? And then once we find what the Z-score is, we look on the chart and subtract.
That's correct. Perfect. So we need to find the Z-score for each of these two individual positions, right? There's gonna be some lower Z-score for this one and some upper Z-score for this one. And then once we have those two values, then we look that up on the chart and then we subtract. So in this case, 18.62 is definitely larger somewhere here. And then 6.08 is smaller. So then we need to find out these Z-scores here. So how do I find the Z-score for 18.62? Well, that would just be 18.62 minus 11.4 divided by 3.8. (18.62 minus 11.4 divided by 3.8). So we get 1.9. How do I find the Z-score for the other position?
we would do the same thing except we would switch. Oh, we just did it for 6.8, right?
Did we?
Or 18. Oh no, 18. So we would just switch 18.62 and put 6.8 instead.
6.08.
Yeah.
So you get 6.08 minus 11.4 over 3.8. Negative 1.4. Any question? Now what do I do? Sorry.
Find both values on the chart for each of the z-scores and then subtract them.
1.9 here and negative 1.4 there. We just look up both those values on the chart. So 1.9,
0.9713.
1.9 is 0.9713 is correct. Very good. So we get 0.9713. And then we have to look up negative 1.4.
0.0808.
0808 is correct. Thank you. 0808. So then we end up getting that this is what? 05. 97 less 8 is 89. So we get 89.05%. Okay.
Quick question.
Yep.
How do you do the subtractions like with the decimals?
Oh, so if you have like, it doesn't matter if it's a decimal or not, honestly. 97 point this thing, like if we had to subtract this number, right? It's the same thing like doing, like if you put a decimal there, same thing, okay?
All right.
Then all I'm doing is, so 3, you can't, 8 doesn't go into 3. So then instead we start thinking of like 13, right? 13 minus 8 is 5, right?
Mhm.
Then 97 minus 8 is, I just said 89. And that's all I said. Then if there's a decimal here, there's a decimal here, a decimal here. Does that make sense?
Okay.
Right? All right, so longer than 16 inches, well, then that just means that we need to determine where 16 is here and then figure out that part right there. So I guess we need to determine the z-score for 16. So then that'd be 16 minus 11.4, all divided by 3.8 or whatever. So then that's gonna be 16 minus 11.4 divided by 3.8. Make sure you do these right on your calculator. All right. 1.21, it's 1.21 approximately. All right, 1.21. Luba, quiet, sorry. So 1.21. So now we gotta look up 1.21 on the table. 1.21 is 8869. What do we do with that? Is that the answer?
Do we subtract 100 minus 8?
That's correct. Very good. So then this is gonna be, we gotta take that away from 100% because that actually 8869 is really this part over here. That's 8869. So then this is gonna be 10 minus 9 is what? 1. 8869 is, what is this? 1, 1, 3, 1. So this would be about 11.31%. All right. Any question?
No question.
No.
All right. Now they kind of are gonna do something slightly different. They're gonna sort of ask you to go backwards. So they're gonna be like, now, so previously what we kept doing over and over and over again was we were doing, given the z-scores. So given like Z lower and Z upper, they were asking us what the area is or what the probability is. Now they're gonna kind of give us something else. Now they're gonna be like, what if we knew the area to the left or the percentile? Now they want to know what is the Z-score now. So it's sort of like backwards. Okay, because before we had Z-scores and we were getting area, now we have area and we want Z-score. So it's sort of backwards. Okay. So now we're gonna look up numbers actually on the inside of the chart here. And then we're gonna try and take them and go backwards and figure out what number they were coming from. Okay. All right, let's see how we're gonna do this. All right, find the Z-score that best satisfies the criterion. 23% of the total area is to the left of Z. Okay. So first you gotta draw it correctly. All right. So if we say 23%, I don't know where that is, but I'm just gonna say it's somewhere over here. Because I know I can't put it over here, because that should be 50 already. So if that's 50%, 23 is gonna have to be over there somewhere. All right, so that's 23%. Now we go to the table and we start trying to find the number that's closest to 23%. So these numbers are too big. You know, this is 70 or whatever. So we start coming over here and it's like, oh, we're getting closer. 23, 23, 23, this guy looks pretty damn close to 23%. So then what number is that associated with? What would the Z-score be associated with this number? 0.2296?
Negative 0.74.
That's correct. Negative 0.74. So all we would say here is that we would say Z needs to be, I guess, negative 0.74 approximately. All right. Does it make sense?
Yeah.
Yes.
All right. 64.8% of the total area is to the left of Z. All right, if I said 64.8% of the total area is to the left of Z, should Z be to the right or to the left of 0? Should Z be on this side or should Z be on this side?
It should be on the right.
Yep. So then somewhere over here, so then this part is 0.6480. So then what should the answer be?
I think 0.308. Like,
Be careful.
That's what I got.
Not 0.308. That's not correct.
okay.
Because this is 0.3.
Is it 7.17? No?
No,
0.38.
0.38 is correct.
Oh,
This is, so this is
Oh,
0.3 and this is 0.08. So 0.3 plus 0.08, you know, that's 0.38, not 0.308. Does that make sense?
oh,
Okay.
okay.
So 0.38, we should say. Any question? So far?
Can you explain the last part as one more time?
64.8%. So this is 0.648. So then this is
Right.
0.3 right here. And
I'm with you.
0.08. So
All right.
0.30 plus 0.08 is 0.38, not
Oh.
0.308. Okay,
Oh, okay. Thanks.
does that make sense?
Yes, sir.
Alrighty. Well, these are the same questions. We already did these. Well, let's just see. How would you do 11?
They're giving you the fraction. Well, they're giving you the decimal.
Yep. So what would I do with those?
Divided over.
Nakamura?
Put
Yeah,
62 over 1.59 or 1.59 over 0.62. No.
No. Nakamura, what were you gonna say?
we
Would
would,
you look up?
yeah, we would look up on the chart and then find the percentage of each, and then we would.
On the chart, right.
And then what would you do? Sorry, Akamura, what was the last thing you said? Then you
Yeah,
would what?
and then at the, we would subtract them, or
That's
would we?
correct.
Okay.
No, that's correct. So 1.59, 1.59 is the last one, 0.9441.
So, question on the exam, are we gonna have the chart?
I said that you need to print it out.
Oh, you have it on D12, so when I print it out.
That's correct.
All right, thank you.
All right. So then all we do is look up these two numbers and we subtract here. So then this is gonna be what, 7, 1, 1, 2?
Two
We get about
yes.
21.17%, whatever that is. So that was really it, I guess. Does that make sense?
Yes.
All right, so I guess that's all. As you can see, this stuff is not nearly as bad as some of the things that we were learning earlier. Let's just go and show you where the thing is on D2L.
Thank you.
No problem. It's in your book also, and it's on your homework assignments. So when you do your homework assignment, it's all there. And there is something you can print from there as well. But I believe I put it in course notes, I believe. Oh, no, it's not on this one. Sorry.
It's under the formula sheets for module F.
Yeah, that I know, but I think I put it somewhere else also. Okay, I made another formula sheets, I think. So out here at the bottom, it says formula sheets. And then it says module F, normal curves, table of z-scores. And I believe, okay, this is the one they give you. Now, I don't particularly like this one because this is the one I was teaching you with. But a lot of your questions on your homework, this one's actually a little easier to use than the one that I was just giving you. So this is the one they're gonna give you on your homework. Then if you go to statistics here, and then I think normal distribution. Then it says this thing, F.5, homework part 3, cumulative Z table. This was the one that I was just using. Honestly, they're all the same. You could use one of them and you could do all the questions with one of them. You don't need to do different ones and stuff like that. Oh, this is just the homework now. Sorry, I clicked the wrong thing. You know what, actually? I don't like having to look through this stuff. I'm just gonna post it right now again on D2L as an announcement. So
Thank you.
Thank you, sir.
don't get me wrong, it's there, but it's just not worth it. I wonder if I can just paste it directly in here. I don't think this is gonna work. It did. Impressive D2L. All right, so here is a Z table for reference. All right, then I'm also going to just link you to a file just in case you want to download it. How do you do that? I'm sure I already uploaded this stupid thing. It's got to be in this course files already. This one should be fine. Yeah, let's do that one actually, because that one gives you the most information. This one gives you less information actually. Sorry, it's just taking a second. We're all done otherwise, so if you want to go, you can go. But the
Have a good evening, sir.
Have a good evening.
Have a blessed one.
You too.
I have a question.
Yes, what is your question?
How will I don't know if it makes sense to say this, but how will I know if I have a good grade in this class? Like,
If you what? Say one more time?
yeah, because like I looking at my grades, like I don't have a specific grade, a letter, but like how would I know if I have a good grade in this class?
Well, I'm gonna recalculate everything and then show you what your numerical score is at the end. But the only thing is we don't have all the grades yet, so I can't really do that yet. Otherwise, what you need to do is you need to take the associated percentages that are written in the syllabus and then calculate the weighted average of your grade, which I can show you how to do that if you want. Or you could just wait like a week or two and I'll post it online for you.
I'll probably just wait and
It's
just
up
do
to
everything I
you.
gotta do.
If you need, right, just do what you need to do. And then if you need me to, I can just help you to see how to do it or whatever. But just let me know. Okay.
All right, thank you. All right, I'll let you know then.
All right.
Okay, have a good one.
You too. Anybody else have any other questions?
Well, mine is just about the attendance thing. And Professor, you almost gave 3 of us a heart attack this afternoon because I was standing there reading reading the notification. So when I said had an accident on the turnpike, they were like, what?
Yeah.
Yes. Yes.
Yeah, I'm not too happy about it. But there's no problem, I'm fine and all that. It's just the, no car. But
I'm sorry about that.
but and the thing is I just got in an accident before, so now here I am, now another accident. But I didn't cause it. It's just I don't know how long this is going to take.
It was raining at the time.
Somebody just sideswiped me.
Wow. Well, I'm happy that you're not in the hospital for one.
No problem with
So,
anything like that. Thank you.
yes.
But
So
this was an important class, so that was the problem, and I didn't want to miss that also. So
okay. Thank you.
but let me post this thing for you guys. Make sure this is gonna look fine and stuff, so we can see this.
Okay. Well, if there's anything else, I'll email you because I see this is what the last class.
Well, I'm gonna come next week.
Thank
but
you.
You guys don't really have to.
I'll be there.
So if okay, so then I'll see you there. So if you have anything you want to talk about, then we can
Yeah,
talk about it.
I'll talk to you then.
But
All right.
the,
Thank you very much.
But here's the post also. So the Z
Okay.
table is posted there, and then also at the bottom here is the file as well. Okay.
Okay, then you have a good one, and I'll see you next. Thank you very much.
All right. Bye-bye.
Okay.
Anybody else have a question about anything?
Yeah, I was gonna ask you if you were all right, but Simone pretty much answered the question.
Thank you for asking. But luckily, no, not that. That's not the problem.
Yeah.
It just took so long to get the car before. Now I'm worried that I'm not going to be able to get a rental, and I don't know what I'm going to do again. I'm going to have to start paying for the rental, and the damn thing's expensive. I don't want to pay for it, and I got the insurance, but they can't fix the stupid car fast enough. So, but otherwise, I shouldn't be complaining. It could be a lot worse.
Yeah, no, I feel you. I was in a car accident too. So
Unfortunately, it won't be the only one you'll be in. Unfortunately,
I hope it is.
hopefully it won't be a bad one. That's all you can say. Like this wasn't really a bad one. It's just annoying. My car's just scraped, honestly.
All right, though.
Thank you for asking, though.
Yeah. I just want to make sure he was okay because I read the news. I was surprised. I was like, damn.
Yeah, no, I appreciate it. Thank you for asking.
All
Could be
right.
better, but all good.
Nope.
All right, well then I guess have a good evening, I guess.
All right, Professor.
Let me
Nice.
know if you need anything and I'll be there next week though. All right.
Okay. All right.